I just want to start you on the assembler CTF. This is all extra credit. You don't have to do it, but if you're interested in learning assembly code, I'd recommend doing it. And so let me point you to that. Then I'll demonstrate a couple of normal projects here to keep us on track. And then I'll have more about the Flare CTF later on, and that'll be in a private Zoom session so people can't record it and I don't get in trouble at Mandiant. And that'll probably be after 7:30. We'll see how it goes. I'm not quite sure when I'll be able to do that, but I probably have to wait till 7:30 and then handle questions that may come in before I do the Flare-on stuff. So let's start with the assembler CTF, which is, this thing is not moving up, there it goes. All right, it's at the bottom here, and it has its own CTF scoreboard, so you don't have to turn these in Canvas. And I cleaned out the old scores, so as you can see, there's only a few students that have done it so far, which is fine. And all right, so the first thing, you have to do this on Linux, which, by the way, is probably the first thing to mention. I had some students say, well, why are we using Linux? Why don't we use MASM on Windows, the Windows assembler? And that's a good question. I just didn't think of that. I think this tutorial that I based it all on used the Linux assembler, and that's what's more natural for me, but you're probably right. For this course, it would probably be better to use the Windows assembler, and I don't know how that would go, so maybe I'll add some projects on that. Another thing I'd like to do, of course, is add ARM assembly, because now I've got the M1 ARM, and therefore I can't do any of these projects on this machine. I have to use a cloud machine using Intel. So there's plenty of ways to go from here. But anyway, this stuff is Linux-based assembly. So let me open my virtual machine, which I have to connect to, and it'll take me a minute, because I opened a SSH port from my machine at home to the cloud, and I added a port number, and I'm not sure I remember the port number, so I have to get it here. Private. I did put information about the private cloud, however, in my password manager. And there it is. Okay, so this will connect me to my private cloud machine. Let me open a command line. All right. This stupid campus network is probably blocking me. Okay, I'm going to have to turn on my VPN, so it may interrupt the Twitch stream. I'm not sure what will happen. We'll see. Okay, that works. Okay. All right, so I've got a command prompt on my machine. Now, let me see if the Twitch stream is still running. I don't know if I have to restart Twitch after changing the networking conditions underneath it like that. All right, so I see Twitch here. And if I refresh it, seems to be okay. Still running. Okay, good. Okay, good. Twitch can survive a switch to the private network. That's cool. I wasn't sure that would work. And now I can get through with SSH on a goofy port number and get to my cloud Debian machine. So, all right, I've got a few examples here to talk about. All right, so the first thing is, all right, so here's the simplest assembly language program, just to be, hello world. So you have a text section and a data section. The data section defines byte. Good, a little 3-second pause. Good, that's very good. So the data section has, you define bytes and you just put in ASCII characters. And then this is a way to turn in the length of a character equals $ minus message. $ is the current location. So this will calculate the length by taking the address at this point and subtracting the address at this point named message. So it'll be the number of bytes from here to there, which is nice. Otherwise, you'd have to put in a fixed number and you have to count these characters. And when you change this string, you'd have to change that manually. This is a cool way to do it automatically. And here's the start section. And here, you see it just loads A, B, C, and D registers, and then it does int 80, which is a syscall. And like we talked about in Windows, everything in Windows is just a Windows API call. And everything in Linux is just a C library call, but all the C library calls are just syscalls. And I think it's true of Windows too. Everything is just syscalls because to get anything done, you have to call something in the kernel. And the kernel you get by just calling in, and these are the parameters that go in. The A is the most important one that tells it what operation, and these other ones depend on that operation. So that's what's going on. And so this thing, you can compile it with NASM. That'll turn it into an object code, and then you link it with LD. So it's a little bit annoying. And here we make 32-bit code, just so you're familiar with 32-bit code to C. So even though you're probably running a 64-bit machine, all of mine are now, you can make 32-bit code on it and see it run, and that makes life a little simpler. So I've already compiled this one, and when you run hello world, it does that. Now let's play some games here. If I, for example, notice, that's not that, so that's the executable, so that's not interesting. But notice it doesn't even print carriage return after the end, which means it sort of appears strangely on the screen like that. I'd like to fix that. Let's go ASM. All I got to do is put a 10 and 13 here. 10 is carriage return and 13 is line feed, or else it's the other way. And since it's automatically calculating the length, it'll automatically extend the length to include those, so this should do it. So let's see if I have that. Yeah, I do. I have the NASM here. So this is hello. All right, and I got the link up here too. I always like to do this. It's easier than trying to type in the fixed command. Having problem to log in, and now added one. Not sure what that is. All right, anyway, hello. Oh, okay, you made a new account called Rouhani1. I see. Well, that's a good solution. Okay. To log in. Good. Good. All right. So now if I run that, there we are. Now it has the carriage return. So
what is the 10 and 13?
10 is carriage return and 13 is line feed, or else it's the other way. So carriage return would take you to the start of this line, and line feed would go to the next line. And those are the two things it takes to move from here to there.
So the hex for the lines?
Yeah. So, I mean, if you look, for example, at ASCII table, you can see it. There you go. 10 is line feed, new line, and 13 is carriage return. So those are the two things you have at the end of every line. That's what you get by pressing the Enter key. Unfortunately, Linux and Windows handle it differently. So Linux, I think, uses just 10, and Windows uses 13 and 10. So you often when you open a Linux file in Windows, the lines don't break. They just all run together, that sort of thing. But anyway, well, the SSH session is cutting off. Thank you for telling me. Oh, yeah, it is a little bit low. Good, thank you. All right, good. I appreciate the information. I need the feedback from you because I don't have enough screens here to keep a good view all the time of what you people are seeing. All right, so we talked about this. Oh, I didn't mention the start location. Up here, this start is the label that tells it where your program starts, _start, so that's important. All right, and so here's some system calls. There's a page that lists them all here, but here's the main ones. This is exit is 1, read and write, 3 and 4. Those are probably the only ones we're going to use, the simplest ones. Read will read from an input stream, like the keyboard, and write will write to something like the standard output, which is the terminal, and you could write to other things like files and stuff, and network connections and such too. So that was using the code to write to the console. So the syswrite is here, EAX is 4, that's syscall, and then if you go here, you see there's various parameters, and the parameters always go in a certain order. And I wonder if it's made clear on this page. This is a standard, an i386. I do not think they bother to tell you on this page. Yeah, not there. But anyway, there is a standard order in which these registers are used. And so the file descriptor goes here into B, a pointer to the buffer goes here in C, and size T count goes in D, so it's just alphabetical. A is the number to tell you which syscall you're doing, and if there's 3 parameters, they're in B, C, and D. And there are other registers used for more parameters. And if you have too many parameters, you put a link to the stack, and the stack has a list of parameters for anything with a lot of parameters, but everything we're doing has no more than 4 parameters. Just the A, B, and C, D registers are all we need. So here's exit. Sysexit, you just move EAX1 and do int80. No parameters is just exit. That's all it is. And I think that's here. So this does a print of that message and a normal exit instead of just crashing. There's the data section. It defines two variables, one called MSG and one called len. And that's, all right, good. All right, and so now there is a tutorial here, which is how I learned to do everything. Everything in this project is just based on what they covered in this tutorial. I sort of went through this thing and made hands-on projects involving each one. It's very, very nice. Has all these sections, and so you'll find it there. And so if you, there's a bunch of things you can answer here that just go through and make sure you've read that tutorial. So this is sort of a quiz. You can get some points doing this if you like. These are just questions that you'll find the answers to in that tutorial. All right, and so I think I won't demonstrate those, but I want to demonstrate some of the, so here's, for example, you can make a head request. So we should be able to do this one. Let's copy hello.asm to head. Whoa, got to copy it to head.asm, okay. All right, and now I just want to make a properly structured head request. And a head request is just those three lines there. Head, a host, and a blank line. So I should be able to figure that out. So let's nano head. All right, so I'm going to print three lines. Now I could put it all in one line. That's probably the simplest answer. I could change absolutely nothing except just change this. I'll probably do that first. That's the simplest solution. Head http:/1.1 1013 host:/ad.samsclass.info 1013 1013. Now that should do it. Let's see if it works. So now I want to compile head, so that is here. And then link head. And then run head. Yeah, it looks like it worked. So if you use Netcat to send that to my server, you'll get the flag. Anyway, so that's pretty simple. And there's other ones down here that get a little harder. Here you have to do a login, and so on. So there's a few things there just to see if you can make simple scripts that write things. All right. And I'm going to stop this video and make a separate video for the next one, I guess. If I can figure out how to get my, here we are.